Okay, well, thank you. Let me pull up my, I've got a, oh, all right, well, I'm gonna share trying to share. Let's see, here we go. Okay. All right, well, it is, Mike, can you see, is this showing up okay, or can you see the full screen or not?
Not full screen yet.
Okay, let me just pull this. It will be in a second. Sorry about that. Okay, how about that?
Yes.
Okay, thank you. All right, well, good morning and welcome to the first workshop on sources and on sort of impacts of fine PM on indoor air quality. Today I have the pleasure, as Dr. Corsi mentioned, of moderating the session and introducing the speakers. And so basically the way this is going to work is there will be 3 speakers this morning that will be talking about outdoor sources of indoor PM. And then we'll have a moderated discussion, which I will lead, which will be where we ask the majority of the questions. And then this afternoon, we'll have another session, but that one will have 4 speakers on indoor sources of indoor PM. And so the way this is going to work is that we'll go through all the speakers. If somebody has like a really burning clarification question, we can maybe, depending on how long the talks go, we can maybe take one, but ideally we'll save the questions for the panel discussion after all of this, each subset of talks is complete. So with that, without further ado, because I don't want to cut into the speaker's time, it is my pleasure to introduce our first speaker, Sunny Ivey, who's from UC Riverside. She is going to tell us today about indoor particulate matter of outdoor origin and the disparities in sources and exposures across communities. Sunny?
Thank you, Kim. So thank you. Hopefully everyone can see my slides. So today, once again, I'm going to talk about more the ambient drivers for exposure and source impacts from both a regulatory perspective and a community perspective. And so I've broken up my talk into 3 sections. First, I'll talk about those potentially conflicting perspectives. I'll talk about our traditional exposure modeling methods and how that may pose challenges for trying to mitigate exposures in the future. And I'll pose a few emerging challenges that may complicate source mitigation and perhaps some new strategies for how we should best approach this emerging challenge. So most people here that are watching out there, we have studied fine particulate matter, its sources, its transformation, and its fate in the atmosphere. And I'm just bringing attention to those phenomena in this nice graphic provided by the EPA. Particularly, my interests lie in understanding how PM2.5 is formed and therefore emitted from various sources on the ground. And I use models to understand the contributions of the various sources to ambient PM2.5. And for example, one of those approaches is this hybrid source apportionment modeling approach that I developed at Georgia Tech as a grad student. And the benefit for a model such as this is that we can actually attribute both primary and secondary particulate matter in the ambient to several different sources, some of which are traditionally unresolved in our receptor modeling methods. And so as an overview, this method involves using a chemical transport model, a nonlinear optimization method, and spatial and temporal interpolations of adjustment factors to improve what we think are the estimates of source impacts across several different sources. And so these methods can be really useful for attributing secondary PM in the model back to sources on the ground during meteorological phenomena such as persistent cold air pool events. And so these PCAP events are quite prevalent in the Western US during the winter time, and specifically in mountain towns. And so this example is for the Salt Lake Valley, where we've conducted our harbor source apportionment model along with some bias corrections, and we determined that natural gas and gasoline mobile vehicle on-road combustion was the biggest contributor to pollution during the PCAP period. And we've also identified refineries and smelters as an issue in this others category, and therefore we can make specific recommendations about how to reduce or how best to reduce pollution during, or PM 2.5 pollution during these PCAPs by targeting nitrate precursor sources. And so now I'll talk more about sources specifically for California. This is where I live, and this is the sources of fine PM. So this is the CARB estimated 2020 emissions of statewide. I've highlighted the primary fine PM emissions here. And the subcategory that is dominant across the state is miscellaneous processes. And if you take a look at this group more in detail, the sources that have been identified are residential fuel combustion, wind-blown fugitive dust, and managed burning and disposal. And as for a reference, this table is in tons per day. I will drill down a little bit further and discuss the top primary PM 2.5 sources in Southern California, where I live, or more specifically, the South Coast Air Basin, which doesn't quite include San Diego, where Dr. Prather is from. So once again, miscellaneous processes is identified as one of the top categories according to the 2017 estimated PM 2.5 emissions in the basin. And specifically, if that's broken out, that's going to be attributed to cooking and paved road dust. So while those sectors have been identified as the top contributors for primary fine PM in the basin, I want to call attention to the fact that when it comes to cancer risk or health effects, the multiple air toxics exposure study, specifically study 4, that's conducted by the scientists and staff at the South Coast Air Quality Management District, have actually identified that the driver for cancer risk as it relates to air pollution is diesel particulate matter. And so this really doesn't show up as one of the top sources, but of course, because diesel PM can be of different origin. And so I'd like to point out that the hot spots for this cancer risk overall are overlaid in what are identified as AB 617 communities. We've got our East LA community, the San Bernardino Musco community, and the community near Wilmington and Long Beach. And so this presents a problem for mitigating exposures that are disproportionately higher in high-risk communities. And so I'll drill further down and speak more about the San Bernardino Muscoy community. And so as an exercise with the local district, they've identified their concerns, what they deem to be the biggest concerns for air pollution in their communities. And they've identified truck idling, truck traffic, a cement plant, specifically the BNSF rail yard, and auto body shops as concerns for them. But then if we look at the breakdown of PM 2.5 sources, according to the district, and this is data taken from the presentation to the technical advisory group, which I'm a part of, the top sources for the San Bernardino Musco community are paved road dust, mineral processes, cooking, residential fuel combustion, light duty, and off-road equipment. And so I'm highlighting these three because these are the three source categories that I think most reflect community concerns. And so these three in the middle are not really highlighted as community concerns. So there could be some discrepancies in what people think are the issues and what the district prioritizes in terms of mitigation. And so now I'm going to talk about modeling methods and how the way we may be going about things may be complicating our estimates of human exposure. And of course, I'm talking about this from an ambient modeling point of view, and I'm happy to be here on the panel with the indoor specialist. So some of these biases are well known in modeling for exposure and health. So for one, you could have a temporal mismatch. I know this is not PM 2.5, but particularly for ozone in the South Coast, we tend to overestimate in the morning and we underestimate in the afternoon. And so when it comes to hourly or acute exposures, if you're relying on an ambient model, there may be some challenges there. The other, what I think is a major source of bias is what I call, or what's known as a change of support problem. When we try to represent individual data points with a smooth or aggregated contour field or grid cell. And of course, this is a granularity issue that is oftentimes presented when we use ambient models for individual exposure assessments. And so the next part of the talk will highlight a review from Alan Goldstein and colleagues, where he's talking about how our traditional methods really don't address the indoor dynamics of exposure. And so some of the highlights from this article are the fact that the size distribution of the ambient PM changes once it crosses the building envelope. And so it tends toward the particles that tend to linger around longer. He cites infiltration factors ranging from 0.3 to 0.8. So, and also he points out the fact that our global mortality studies oftentimes neglect the role of buildings as attenuators and modulators for exposure. And so the rest of the panel will talk more about this in just a few minutes. The other thing that poses a challenge is the fact that humans move around during the day. And so my colleague Hao-Fei Yu from the University of Central Florida, he led a study of which I was a part, where we're comparing the exposure to PM 2.5 based on what's called a call detail record and versus the home-based exposure. This is driven by CMAQ data. And what we see here is that people that are less mobile or people that are more mobile have a higher likelihood of having their PM 2.5 exposure misclassified if you're using a home-based modeling method. Another interesting study that that Hao-Fei led is the fact that perhaps Google Maps location history is a nice tool for characterizing time activity patterns. Of course, this has to be privacy has to be considered. And if this were to be used, people would have to consent to having their data used for exposure purposes. And with all that said, my specific interests were to understand how human mobility serves to impact personal exposure disparities, specifically for PM 2.5. And most of you have already heard me talk about this before. I carried out a pilot community-based participatory research field campaign in the spring of 2019, where I recruited participants from Moreno Valley, Redlands, Riverside, San Bernardino, and Yucaipa here in inland Southern California. And so the San Bernardino community is our disadvantaged community. And I recruited these people, about 18 adults, to carry these wearable packs where we use the applied particle technology sensor or monitoring unit to collect 15-second PM 2.5 data. And they also carried a GPS data logger, which sampled at a rate of 5 seconds. And so after correcting the measurements to the reference monitor and clustering those measurements into 7 or so microenvironments, And aggregating the data sets where we had more than 50% data recovery, we found the major finding here is that their home-based personal to ambient ratios were a lot higher for our San Bernardino community compared to our Riverside and Redlands community, which are much higher along the lines of median household income and poverty rate. And so this lends the fact that perhaps when it comes to mitigation, we do need to consider people's personal behavior. So this study builds on or builds a foundation for using these methods for larger exposure assessments, particularly that's facilitated by wearable sensors as well as GPS data loggers. And the other thing that I want to point out is that perhaps exposures during visitation to what I call high-risk non-residential points of interest should probably be continuously monitored, because in our study, our participants spent about 30% of their time away from home. And lastly, I'm going to bring about some emerging challenges. So for one, we may have to consider a new paradigm for how we want to address PM 2.5 exposure disparities and therefore the mitigation. And so we'll probably have to consider these approaches through a historical lens, where we consider the inequities that may confound our approaches. And we can do this by classifying these exposure disparities as either intentional or unintentional. And so what I mean by an unintentional exposure disparity is perhaps one that is not impacted by humans directly. So one of those examples is wildfires. So we can't control roughly where a wildfire will start. I know there's some different opinions about that, but in comparison here, we're seeing this work by the Center for the Built Environment at Berkeley, where the tightness of the building seal is going to impact the pollution indoors during a wildfire. And so the way we mitigate this is a little bit different from the way we mitigate, say, an intentional exposure disparity. So what is driving these intentional exposure disparities is inequities in land use. And so where someone lives oftentimes determines what sources are in proximity to their homes. For instance, in the Inland Empire, there are several residential communities that are right next to warehouses, or some of them are next to natural gas bus refueling facilities that power the city bus fleets. So this poses problems when it comes to mitigating inequities in source-related exposures. And so we can tackle that perhaps by passing legislation that ensures that disadvantaged communities no longer bear a disproportionate burden of pollution and environmental hazards by way of land use equity. So some of the take-home messages that I'll talk about here is the fact that air pollution modeling has paved the way for our understanding of source-receptor relationships, and it allows us to assess health impacts at a population scale. However, misclassification and confounders for these associated with these methods, they complicate our understanding of exposure disparities and therefore mitigation strategies. And so we really need to consider the building envelope in our methods so that we can plan for the future and improve our health assessment methods. Moreover, mitigating these exposure disparities will require an intense commitment to sustainable and equitable zoning and development. With that, I'd like to thank my collaborators. I'd like to thank the committee for inviting me to speak, and please feel free to contact me if you have any questions. Thank you.